Hello friends. Hello friends. The new article from the chapter Electrostatics is a capacitor. In in section second, for when you study the electricity, then we study the conductor, resistor. In the same way, one more small apparatus is called as the capacitor. What is the capacitor? What is the use of capacitor? That you have to study in this article or in this lecture. First of all, see what is the meaning of capacitor. This capacitor is word related to the capacity. What is the meaning of capacity? Capacity's meaning is very simple. Ability of a body to do something. Okay. Suppose just I am taking a one bottle and I am storing that bottle and storing water inside that bottle or storing liquid inside that bottle. Then just I want to check how much water is stored in that bottle, maximum how much storage of that bottle. Then at that time we study the capacity of that bottle, means how much quantity is stored. In the same way, in a capacitor, we store the charge. Okay? We store the charge, means ability of conductor to store the charge or to hold the charge is called as the capacitance. And which conductor stores the charge, that conductor is called as a capacitor. Okay? Now we see first clearly how the capacitors are formed and all the things. This is the one conductor. This is my first conductor, and on this conductor, charge plus Q is given. So the charge plus Q is on the first conductor. Now the charge is uniformly distributed over the surface of the conductor. Now on the conductor, charge is plus Q. So the potential of this conductor is a V1, is a potential of the conductor. Now taking one more conductor, this is my second conductor. Identical, the charge is given minus Q. So the negative charge is uniformly distributed over the surface of the conductor. Now the electric field and its potential is V2. The electric field arises or electric field is produced, electric field is developed between the two plates of the conductor 1 and 2. Okay. Now how that electric field arises? Everyone know that electric field is always start from the positive charge. So the electric field, it will be shown by the arrows, and the electric field move from positive to the negative charge. Now the next thing, when electric field move from positive to negative charge, when any other charge, when any test charge is moved from first conductor to second conductor, then work done is positive, because we are displacing charge in the direction of electric field. And suppose a test charge is moved from second conductor to the first conductor, then work done is negative, because we are displacing charge from negative to positive, means opposite to the direction of electric field, against the direction of electric field. So the work done is negative. Now here we are displacing a one test charge from second conductor to the first conductor, means in this case my work done is negative. Okay, work done is electric potential energy, and it is given by 1 upon 4 pi epsilon 0 Q1 Q2 this divided by R square. No, Q1 Q2 divided by R. This is my electric potential energy. Now first we see how much potential difference is generated here. The potential difference means simple, the difference between the two potentials. It will be symbolically expressed by V. Potential difference means what? V1 minus V2 or V2 minus V1. Now it will be very simple. When you take the difference, at that time take larger minus smaller, larger minus smaller. Here positive charge is there, so its potential is a positive. Positive is always a greater, and here the charge is negative. Its potential V2 is always a smaller, so potential difference becomes a V1 minus V2. And this potential is nothing but my work done, and work done or electric potential means it is work done because the distance is remains same. Only it will be depends on the test charge. How much quantity of test charge? Let the test charge be the plus Q. The test charge displaces from second plate to first plate, or the test charge displaces against the direction of electric intensity, against the direction of electric field. So the work done is obviously my work done is negative, and that work done or electric potential is directly proportional to the charge, because from this end to the top end distance is remains same. So 1 upon 4 pi epsilon 0 r, this charge is same. The only depends on how much quantity of charge is it displaces in electric field. So it will be proportional to Q. So V is proportional to Q. Now remove this proportionality sign and we add a one constant. Therefore I am adding a one constant divided by Q. So term becomes V upon Q equals to constant. Then this V by Q, this constant is nothing but my capacitance, and it is symbolically expressed by C. So my formula for capacitance becomes C equals to Q by V. This is the formula for capacitance or capacity of conductor or capacitance. Capacitance, C-A-P-A-C-I-T-A-N-C-E, capacitance is given by C equals to Q by V, means charge upon potential. It is the ratio of charge to potential, means capacitance. Now theoretical question arises. On which factor capacitance of a conductor depends? So number of students gives. It will be depends on potential, it will be depends on charge. No, this is a totally wrong answer. Capacitance depends on the first factor is size, shape, or is simply area, dimensions of conductor, or simply the area of the conductor. Second, it will be depends on distance between the two plates. And third factor is in between these two plates which medium is present. So it will be depends on dielectric constant of the medium. On these factors capacitance of a capacitor depends. So remember this one. Just pause the video and write down these things. Now what is the SI unit of capacitance? Now everyone knows unit of charge is coulomb. Unit of potential is volt. So or simply just I am writing in this way. Unit of charge is a coulomb. Unit of potential is a volt. Therefore the unit of capacitance is very simple. Unit of capacitance is farad, not Faraday, it is a farad, and 1 coulomb upon 1 volt equals to 1 farad. Symbolically expressed in this way, 1 farad equals to 1 coulomb upon 1 volt. So how you define the 1 farad? It will be very simple. When 1 coulomb charge is added to the conductor, then its potential difference rises. To rise means increases by a 1 volt. Then the capacity of conductor becomes a 1 farad, or 1 farad is defined as the potential difference of the capacitor or potential difference across the two ends of capacitor increases by 1 volt by adding a 1 coulomb of charge, that is a 1 farad. Remember that farad is not a small unit, farad is a larger unit, it is a much larger. So when you take in numericals the farad, then the capacity it will be never in a farad. Okay, it is in terms of microfarad, nanofarad, millifarad, picofarad in this way. Then what is a 1 microfarad? Means it is a 10 raised to minus 6 farad. Okay, 1 nanofarad means how much? Nano means 10 raised to minus 9. So 10 raised to minus 9 farad. 1 millifarad means how much? Then a 10 raised to minus 3. 1 picofarad means how much? Then 10 raised to minus 12 farad. Okay. Remember, these are the conversions. This is most important for the numericals to convert the microfarad to farad, nanofarad to farad, picofarad to farad, millifarad to farad. Remember what is then? Now it will be clear. The capacity means what? Capacity means ability of conductor to hold the charge, but it is not the most accurate definition. When you study the next part, at that time we see what is the exact definition of the capacity of the conductor. Okay, just pause the video and write down these things. I am not erasing the first video. Now this is my initial case, okay, as it is. This is my V1, this is my V2. Don't confuse. For this diagram, V equals to V1 minus V2, then C equals to Q by V. This is, it will be very clear. Or just we have to write down C1 equals to Q by V. In second case, this is a same plate, okay. This is my first conductor, plus Q charge is given to the conductor. So what happens? Charge is uniformly distributed over the surface and its potential becomes a V. Not I am taking the V. Here the potential becomes a V. One more plate which is separated by a fixed distance. This is my second plate or second conductor given a charge minus Q. So the charge is distributed here. This is, if you say, sir, there is no any difference between the two diagrams. No, not in this way. There is a wide difference. This second plate is earth. Earth means what? It is connected to the ground. It is connected to earth. Means excess charge, it will be flow. Okay? Now it will be the earth. Then what happens? Here the positive charge, negative charge, positive charge, negative charge. Obviously, the positive and negative charge are bound with each other, Then the electric field move from positive to negative charge. Means obviously some free positive charges move here. When the positive charges move here, because there is a negative charge, so and it will be earth, which it will be charge, it will be free to move. Therefore, when a positive charge, excess positive charge or induced positive charge is moved in between the field, then what happens? Then its potential is V1. Because of this free positive charges, the potential at the second plate becomes a less. So new potential V dash equals to how much? It is a V minus V1. This is my new potential. The definition becomes how? Capacitance is given by C divided by Q by V dash. So it becomes a Q by V minus V1. Let this capacitance equal to C2. Now check here what is the potential. Capacitance C equals to Q by V. Okay, when earth is given, when second plate is earth, then what happens? Then Q, it will be remain same. Instead of V, the factor arises V minus V1, which what happens? My denominator decreases. Okay, just I am writing here. C1 equals to Q by V. C2 equals to Q divided by V minus V1. Here Q is same. Here V and here V minus V1. Here denominator decreases. If the denominator decreases by V1, then which quantity is greater? C1 is greater or C2 is greater? Yes, obviously the C2 is greater than the C1. Means what happens? Capacity, same parallel plate diagram, identical material, but how you increase the capacitance? Just second plate is earth, then what happens? Then a capacity of that conductor increases. Okay, remember for objective type of questions, if the two parallel plates are there, then how you will increase the capacity? Number of options are given, but one correct option is what? If the second plate is earth, then what happens? Capacity increases. If the second plate is earth, means what happens? Here potential decreases. Means now the question arises, in both the cases, which capacitor is easy to handle? First one or second one? This is a one capacitor, this is the second capacitor. Which one is easy? Which one is very simple to handle? Then in the first case, its potential is greater. Potential is greater means what happens? If the potential is greater, then the potential difference is also greater, because we are earth, means we have the zero potential, and it will be at the higher potential, so difference is higher. Here what happens? It is already earth, means its potential reduces. Therefore, there is no possibility of shock, electric shocks in second case. Therefore, which is very easy to handle? The second capacitor is very easy to handle because it is a earth. Therefore, remember that. Now, capacity will be remain same. In second case, capacity increases. But how it increases? By decreasing the potential or by lowering the potential. Therefore, the definition of capacitance is like this: ability of conductor. Everyone write down this. Ability of conductor to hold or to store charge at low potential is called capacitance of capacitor. Ability of conductor to hold or to store the charge at low potential. Important word is what? Low potential. In our previous definition, just we say ability of conductor to hold the charge, to store the charge. But the accurate definition is what? Ability of conductor to hold the charge or to store the charge at low potential is called as the capacitance of the capacitor. How the plates are there? The plates are parallel. So the symbol of capacitor is just we are drawing the two parallel plates. This is symbol of capacitor. And if you draw in this way, one at higher length, another one at lower length, then it becomes the same. So don't confuse. This is my example. Okay, two parallel plates of same length. That is my capacitor. Okay, is it clear for everyone? Yes. Okay. Then take one screenshot and write all the parts. Now we see the next part of this. For any electrical circuit, is consists of number of capacitors. Now there are the combinations of capacitor, like a resistor. Resistors are connected in a series combination, in a parallel combination. In the same way, the capacitors are connected in a series combination and in a parallel combination. Just I am making two parts of the board. First, please see the series combination. It is very easy part. Don't afraid about this part. Series combination, and second combination is my parallel combination. Okay, just see the series combination. I am taking the three capacitors. These are the three capacitors are connected to a one cell. The potential of the cell is V. The capacitance of first capacitor is a C1, for second is a C2, it will be the C3. Now from this cell, Q amount of charge is flowing through the circuit. When Q amount of charge is flowing, let this plate is a positive, 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 it is negative, again it's a positive, 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 negative, positive, negative, negative. Okay. Now when a Q amount of charge is flowing, the charge is flowing in the same way and without distributed form. Means if 1 coulomb of charge is flowing, or suppose 3 coulomb of charge is flowing, then from capacitor C1, from capacitor C2 and from capacitor C3, 3 coulomb charge is flowing. Not it is distributed as a 1 coulomb, 1 coulomb and 1 coulomb. So in a series combination, charge is not distributed. This is very important. Or charge flowing through each capacitor is same, or simply charge on each capacitor is same. This is my first point. Charge on each capacitor is same. So on the first capacitor, charge is Q. Second capacitor, charge is Q. Then I will draw charge by different color. So the charge on first is Q, on second is also Q, on the third is also Q. If the Q is same, C1 equals to Q by V naught, Q by V1. So the potential difference is different. So this is a V1, this is a V2 and this is a V3. Now remember that what is the V? Total V becomes V1 plus V2 plus V3. What is the definition of C? C equals to Q by V. So convert the formula. What do that? V equals to Q by C. So it becomes a Q by C equals to V1 becomes C1 equals to Q by V1. So V1 equals to how much? Q by C1. So it becomes a Q by C1 plus Q by C2 plus Q divided by C3. Now the next step, Q it will be taking as a common. So if I take the Q common, 1 by C1 plus 1 by C2 plus 1 by C3. So Q get cancelled. 1 upon C equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Means when capacitors are connected in a series combination, charge on each capacitor it will be remain same. And potential difference across each capacitor is different. Then next thing, 1 by C, that is in series combination. So I am writing here CS equals to 1 by C1 plus 1 by C2 plus C3. If the 4 capacitors are there, then it becomes a 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4. If there are n number of capacitors, then formula becomes up to 1 upon Cn in this way. Okay. Now the next step. If just to tell here, if C1 equals to 2 farad, C2 equals to, okay, just I am writing here microfarad, C2 equals to 2 microfarad, then what is the value of CS? It will be very simple. 1 upon CS equals to 1 by C1 plus 1 by C2. So it becomes a 1 by 2 plus 1 by 2. Then we write the common unit microfarad. So 1 upon CS equals how much? 1 by 2 plus 1 by 2, it becomes a 2 by 2, it becomes a 1 by 2. Are you getting that? Then CS equals to how much? It's a 1 microfarad. Or simply can I write in this way? CS equals to identical capacitance divided by number of capacitors. Because identical capacitance is how much? 2. And how many number of capacitors are there? 2. So the formula becomes 2 by 2 equals to 1. Just take one more example. If the 3 capacitors are there, let it is all are identical. Its capacity is also 2 microfarad. Then my answer is very simple. The answer becomes a 2 by 3. Just we check. CS equals to, again the man substituting the formula 1 by C1 plus 1 by C2 plus 1 by C3. So 1 upon CS equals to 1 by 2 plus 1 by 2 plus 1 by 2, it becomes a 3 by 2. But it is what? It is about 1 by CS. So CS equals to how much? It is a 2 by 3. And if I am using the shortcut, identical capacitance divided by number of capacitors, then formula becomes what? Identical capacitance is how much? 2. How many number of capacitors are there? 3. So it becomes a C by N. If n number of identical capacitors are there, if n number of identical capacitors, then capacitance in series combination becomes Cs equals to C by N. This is a simple or shortcut trick. This is about the capacitance are connected in a series combination. Now see the next type of combination when the capacitors are connected in a parallel combination. Just again we are making the three capacitors, that these are my three capacitors. All the three capacitors are connected in a parallel combination. Okay, here the potential is connected with the cell, its potential difference is a V. Capacitance of each capacitor is C1, C2 and C3. Then the charge, it will be Q amount of charge is flowing from this source. Q amount of charge reaches at this point. Then what happens? Then towards this Q1 amount of charge is going, Q2 amount of charge, Q3 amount of charge. Here what happens? Charge is distributed. I am not telling the charge is uniformly distributed. If all capacitors are identical, then charge is uniformly distributed. If capacity of each capacitor is different, then obviously the charge is also distributed in a different way. It will be not distributed as the uniform distribution. Okay, but all the three capacitors are connected in a parallel combination. Therefore, one thing is clear, that their potential difference is same. So the first point is very important, is that potential difference on across each capacitor is same. Second, charge on each capacitor is different. Capacitor is different. Now we check the formula. Now V, it will be remain same because all are connected in a parallel combination. So total charge equals to what? Q1 plus Q2 plus Q3. So general formula is what? C equals to Q by A. So Q equals to what? CV. So it becomes a CV, it becomes a C1B, C2B plus C3 into. Now it will be very simple, taking V as a common inside the bracket, we are getting C1 plus C2 plus C3. So VV get cancelled. Effective capacitance becomes C1, C2 plus C3. If n number of capacitors are connected in a parallel combination, then CP becomes C1 plus C2 plus C3 up to dot 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 Cn. Okay, so I am writing the formula. Cp equals to C1 plus C2 up to Cn. Just mention to C3 उसमें लिख दिया तो सही. If n number of identical capacitors are there, if n number of identical capacitor of capacity C, then parallel combination capacitance becomes Cp equals to n times of C. How it is a n times of C? That we have to see. Cp equals to C1 plus C2 plus C3. Let's take the same example. If C1, C2, C3 all are the same and effective capacitance is of 2 microfarad, then it becomes a 2 plus 2 plus 2. It becomes a 6. 6 means what? 3 times of 2 means a 6. Yes or no? 3 into 2. So I am writing here number of capacitors are 3, identical capacitors are C. Now one more question. Which combination gives effective capacitance more? Answer is very simple. Here what? N times of C. Here is what? C by N. So in series combination effective capacitance decreases. In parallel combination effective capacitance increases. Okay. Just pause the video and write down all the part. these are your simply distinguishable points between series combination of capacitor and parallel combination of capacitor. This is standard formula and this is the trick when identical capacitors are